Hello, my name is Joseph Monroe, and today I'm accompanied by Richard McMullen and Boxx. Today, we're going to be discussing photonics and the future. Before we delve into this deep, diverse topic, I'd like to show you a quick video brought to you by Creole UCF. Now, that cool little graphic displayed some of the many applications of photonics, and it's all about what can be made possible with a single beam of light. Now, everywhere I go, people ask me, what's your major? It's the go-to question whenever you're trying to get to know somebody here on campus. And every time I tell them I'm a photonics and optical science engineer, they hit me with the, what's that? Luckily for us, our college, Creole UCF, has given us a nice, concrete definition of what photonics is. Being simply put, photonics is the study of light and its uses in light-based technologies. This looks like scanning devices. This looks like devices that project images to us, and a multitude of other things. Now, what's the relevance? Why are we here? Why are we telling you this information today? We're doing this because we are photonics majors. We're interested in getting into career-based work and research in this field, and it has everything to do with us as we've decided to spend the next 4 years on campus doing photonics-related work. Now, what is our purpose? This presentation explores how photonics, a rapidly evolving branch of engineering, is set up to play a pivotal role in shaping future technologies, and as such requires much more recognition in the academic community. Photonics is the future, and people need to know about it because pretty soon it's going to be in nearly everything that we do. Now, let's talk about the demand for photonics. I'm not making this up, guys. It's on the rise. Looking at this chart brought to us by Straits Research, they forecast between 2022 and 2030 that there will be a 7.3% increase in the total market value of photonics technology, capping at $1,100 billion by the year 2030. $1,100 billion. And that's all in a research and a technology in the field that many of you have never even heard of. Now, I know what you're thinking. Photonics, what is it? What does it do? We're gonna get right into it. But firstly, let's compare that demand to the amount of undergrad students that we have per year. As of 2023, there were a total of 115 photonics graduates. 115. Compare that to business majors, to mechanical engineers, to any other discipline, it skyrockets. And here at UCF, we provided 50% of those graduates. Obviously, there's going to be a large rising demand for photonics engineers, and obviously, we're not providing enough photonics engineers to meet that demand. Now, I'd like to pass it on to Richard McMullen.
Hello, my name is Richard McMullen, and I'm going to break down the different applications of photonics. First, I'll start with security and defense. Recently, photonics has started to play a pretty big role in security and defense in the United States government and military. One up-and-coming technology in the U.S. military is light detection and ranging, also known as a LiDAR. LiDAR was once a very niche technology that was mainly used for autonomous vehicles, but now LiDAR is extremely important to military operations in the U.S. LiDAR can be used for many different things on the battlefield, from counter-drone systems to high-resolution maps of the battlefield, which can help with situational awareness. LiDAR is rapidly developing and becoming extremely important to modern warfare. Now, as the demand for high-speed 5G internet continues to grow, photonics has emerged as a cornerstone technology in modern telecommunications. Telecommunication systems with photonics revolve around the use of photons to transmit, process, and store data. Unlike past electronic systems that focus on the electron, photonic devices take advantage of the unique properties of light to achieve unmatched speed and efficiency. Some of these devices include optical fibers, wavelength division, multiplexing, lasers and light sources, photodetectors, and optical amplifiers. Photonics in healthcare or biophotonics involves the interaction of light or electromagnetic radiation with living organisms. Over the past 20 years, photonics has rapidly and selectively detected diseases. Additionally, many optical imaging methods are used in clinical setups to detect different things in the human body. Things like molecular imaging uses photonics to access cellular data and molecular processes in living organisms. Laser radiation through optical fibers is commonly used method for targeted treatment of tissues. And with recent advancement in biophotonics, it is now possible to differentiate between the different tissues and stages of cancer with the help of artificial intelligence. Lots of research is being done today to see how photonics can improve the medical field, as cancer therapies are using photonics are being studied. Photonics also plays a very important role in modern manufacturing, as it has significantly improved efficiency, precision, and speed across manufacturing industries. An example of how photonics is extremely useful in manufacturing process is defect detection. In defect detection, high-resolution cameras are used alongside of imaging techniques so that the manufacturer can detect the defects, measure dimensions, and check the product quality across various stages of the production. Additionally, with the rise of photonics in manufacturing, laser technology provides a high-energy focused laser that allows for precise and accurate material processing, such as high-speed laser that can cut without having to come into contact with the material. Photonics is not just limited to these things, as researchers are continuing to study and experiment on what can be done with photonics. Many things that photonics is involved in that I don't have time to discuss, like photonics in space, computing, energy, the environment, and also research. This is what makes photonics truly so fascinating, is because of all the stuff you can do with it. Now I'll be passing it along to Boxx.
Hello, my name is Boxx, and you've heard my teammates talk about a lot of the stuff you can do with photonics. So I'm here to tell you about some career pathways, about how you can actually go about doing these things. I got a few examples here because there's just so many. So the three examples I've gotten, we got laser engineering, optical fabrication technician, and fiber optic engineering. These are just three examples just to showcase some of the versatility. So a laser engineer is fairly self-explanatory. They're an engineer that deals with lasers, setting up laser technology, maintaining it, making sure it's all safe, all that sort of thing. Optical fabrication technician is quite different, but also a little similar. An optical fabrication technician is someone that works with glasses and lenses and studies how light bends and how to take advantage of that. And then fiber optic engineers obviously deal with fiber optics, which is internet, networks, fiber optic network systems, all those sorts of things. So the schooling for these are fairly similar. Laser engineering and fiber optics engineering both take bachelor's degrees, while an optical fabrication technician is actually a trade school. It's a technical job. And then got some examples of each of those here. So what exactly are we here to tell you? Overall, photonics is a very versatile field. It's because it's dealing with light. There's a lot of things we know about light, but there's also so much that we don't know. And that's really what photonics is. It's a rapidly growing field, like we mentioned. There's so many different practical applications, so many different fields that deal with it. And basically, light can do anything. It's a wave, it's a particle, and it's our job as photonics majors to take that light and see what we can do with it. We're gonna go out into the world and there's just too many applications to cover. And versatility is the name of our game. So, once again, I'm Boxx, joined by Richard McMullen and Joseph Monroe, and this is our presentation. Thank you very much.
Okay. Oh wait.